Hey, Vlad here, devinsideyou.com. Welcome to another video. In the previous video, we started to play around with Monocle and we even created our own lens implementation. And in the video before that, we played around with Chimney, which allowed us to go back and forth between two data structures with ease. Today, we're going to talk about other lenses in Monocle and also make sure that all of them abide by their respective mathematical laws. And also, as announced in the previous video, Chimney is going to make its comeback. So let's not waste any more time and roll the intro. Exactly as in the previous video, we're inside of Visual Studio Code, which runs inside of Ubuntu 18.04 virtual machine, and I'm using Windows as a host with the virtual desktop feature, which allows me to go back and forth to Windows and Ubuntu. If we go back to Windows, and I'm going to open my browser, which is already opened at the Monocle's website, and I'm going to click here on Optics, and I'm going to zoom out a little bit like that. We're going to see quite an intimidating diagram of all the optics, but it's actually not that intimidating. I'm going to walk you through most of them, but today we're going to concentrate mostly on these four. As a reminder, all optics zoom into something. For example, a lens, it zooms into a field of a case class, or mathematically speaking, it zooms into a factor of a product. But as you can see here, lens is not the beginning of the story. A couple of words about the diagram itself. Even though this is not how the optics are implemented in Monocle, you can think of this diagram in terms of a hierarchy, right? In terms of subtype polymorphism, right? So a lens, for example, is an optional, and an optional also is a traversal. A redesign of Monocle is being considered for Monocle 3. For now, we're still in Monocle.2. So if you wanted to, for some reason, convert a lens into an optical, there will be a helper method on lens called as optional, as said as optical. Okay, so you can do lens dot as optional, or you can go straight to lens dot as traversal, right? Because transitively, because a lens is an optional and optional is a traversal, a lens is also a traversal. Another thing to know about the diagram is that the way optics are designed inside of Monocle and also in general conceptually is that the higher you are in the diagram, the more applicable they are. So there are more and more situations in which they are applicable. And the lower ones are stricter, which is a two-edged sword, because even though you cannot always apply a lens, when you do, you have stricter guarantees, and therefore you'll have less complexity to deal with. Let me actually maximize my Chrome real quick, and let me go through the entire diagram real quick, and after that we're going to have actual code examples for, especially for these four. Okay, so an iso is the short form of isomorphism, which comes from Greek, and it basically means same form. For example, you can have two types, and to the compiler they will be different, right? So let's say they're called source and target, and the compiler thinks that they're different, but you as a programmer know that they're actually the same. So if you create an isomorphism or an iso, then you will be able to go back and forth. And by the way, does that sound familiar? As you can see, isos are at the bottom of the diagram. This is because they are the most strict options. They offer the best guarantees. They allow you to go from source to target and from target to source always without any loss, which is a really, really nice guarantee to have. But on the other hand, it sounds so simple that you might be wondering, why would I ever need an ISO? But you will see it later. For now, let's talk about lenses that we talked about in the previous video, so we're going to make this one short. Another way to look at lenses is a relaxed isomorphism, right? So a lens always allows you to go from source to target, right? So you can always zoom in from a case class into a field, but in order to come back, just a field is not enough. You also need another source, right? So if you want to inject a street name, you need to know where to inject it to. So you need the street name and another source. You can combine them together and you create another source. A prism, on the other hand, is like a mirror of a lens. Lenses are for products, aka case classes, and prisms are for co-products, aka sometimes, aka ADTs in Scala, or algebraic data types, where you have a sealed abstract class or a sealed trait, and you have a bunch of versions of it, right? So prisms are a bit harder to imagine, and therefore I'm going to give you an example, and a bit later we're going to see exactly the same example in code. Simple example, you have the traffic light. It can be red, green, and blue, and now you can create a prism that will only zoom in into one of them if it's green. Right? So essentially, you can't go always from source to target, but you can go from source to an option of target. However, being a mirror of a lens, you can always come back, right? Because a green is always a traffic light. So you can always go from target to source, but going into the target, doesn't always work. So to recap, ISOs offer the best guarantees. They can always go from source to target and from target to source. A lens can always go from source to target, but in order to come back, it needs another source. And a prism sometimes fails to retrieve the target, but at least it can always come back to a source. You can think of optional as a combination of lens and prisms. In fact, it takes the worst parts of both of them. It can fail to retrieve a target from a source, and it can also fail to retrieve a source back from the target. We're going to see examples of optionals later. Now, let me also say a couple of words about traversal. We're not going to deal with traversal and folds in this video, but essentially all of these lenses before, they had some notion of failure, right? So an ISO can never fail. It can go back and forth. A lens needs some extra information. A prism can fail, and an optional also can fail even in both directions, right? So it has a notion of an option. And an option can be viewed as a list with one element. Traversal removes this restriction. As I already mentioned, the higher you get, the less restrictions you have. Okay, so a traversal basically allows you to set not only like to fail when you set something or modify something, but you can actually set things to multiple places, right? So for example, you can set a new street name into a list of addresses, for example. Fold is pretty much exactly the same as traversal, but notice that it's all the way on the left over here, far away from the setter. So it works exactly the same as traversal, but it can't set anything, right? So fold is the abstraction of fold left and fold right, so it can just read the information and collapse it into something, but it cannot set anything. Just as a reminder, to avoid some confusion, the Scala standard library has a collection called traversable. Optics has a traversal, and Cats has a traverse. Okay, they're all super related, but they're not the same thing, right? So traversable in Scala standard library is a collection, traverse in Cats is a type class, and traversal in Monocle is an optic. All right, so we're pretty much done with the diagram. I didn't say anything about getter and setter because they're pretty much straightforward. One thing to note is that notice that the getter is all the way here on the left. So basically only an ISO and lens, they have a get. A prism, optional, and traverse. Basically prism and optional, they have get option, right? So you have get option, and over here you have get all, and over here you also have get all. All right, so let me go back to my VM, and we have exactly the same main as in the previous video. In fact, it's not exactly the same. I cleaned it up a little bit, and I didn't want to waste your time. But essentially, we're importing a bunch of things from Monocle, and we have our flat person. I'm actually going to collapse him. We have a nested version. We're printing both of them out, which is over here, these two. And then we have a helper called styled, and we're printing out a lens modification, one for street name, one for zip code. And then we have a bigger example with the validation over here, where we also transform the age, right? But that's it. We have these 50 lines. And in fact, what we're going to do now is we're going to comment it out, and we're going to create another main, and we're going to start things a bit more slowly. But we're going to go back to this one as well. Okay, so let me do object main extends app like this, and I'm going to copy that. 75 like that. I'm gonna copy that. Okay, let's just see that it works. Okay, we should see just the two lines. Okay, so we're gonna start with the isomorphism. We're gonna start at the bottom, right? So in the previous video we started with lenses. This was somewhere in the middle, but it had a reason. Lenses are the most prominent optics. All right, so what we're gonna have is we're gonna have a final case class dog, which has a name. Name was a string, and we're gonna have an owner, which has a name, and a pet, which is a dog. All right, so now let's imagine that we have a couple of types. We're going to have a type A, right, which is a tuple of int, a string, and a dog, right? So this is a tuple 3 or tuple 3. I still have no idea how exactly to pronounce them. Okay, now let's have a type B, which you as a programmer will know that it contains exactly the same information, but at the second position is going to have another tuple. So we're going to have string and dog, right? So to you, we know that it contains exactly the same information, but to the compiler they're different things. Okay, let's also just for fun have a type C, which is going to be not a USB type C, just a type C. It's going to be int and owner. And if you look at the owner, it matches exactly these types, right? So all of them are set to be isomorphic. They're basically the same, even though to the compiler they are different. So you can go and you can create an ISO AB of type ISO A, B, and notice that I have I have the universal imports over here, so we're not importing just lenses, we're importing basically ISOs as well. Okay, and we can go and can create it same way. We can say ISO A, B, And we also need to give it to a function. The one function will go from A to B, the other function will go from B to A. And we're going to use partial functions, so we're going to do that. And the second one is going to be over here. Okay, basically it's super simple. We're just going to deconstruct the A, which is int string dog. Okay, and arrow to the right. Now we need to produce a B, which is going to be int. And over here, we're going to have string and dog like this. And going back is going to be exactly the same. In fact, the syntax allows me just to copy them. I can just do this, and I can just do that over here. Let's see if Scala FMT is happy. Yes, it is. All right, so now we can do the same thing from B to C, for example. Okay, so I'm going to do val iso bc iso bc equals iso b comma c equals, and we have the getter, and we have the reverse getter, so to say. Okay, so now we're going to do a case, and because we have a B over here, I can just simply copy it over here, right? So this is our B. Okay, like this. I can just do that. Okay, we don't have a C yet, so I actually have to type it out. So we have int, and we need to wrap this thing into owner, string, and the dog. Okay, going back, we can just copy that, case, copy that, arrow to the right, and we need to go back to exactly the same thing. Okay, now we're going to play around with them a bit later. For now, let me show you that you can compose an ISO with another ISO, right? So if you have ISO, we're going to go from A straight to C, right? ISO of that goes from A to C equals ISO that ISO, hold on. The point is that I don't want to create it, right? So we're going to take ISO AB, and we can basically just compose ISO, right? Notice that there are multiple methods, right? So there's compose ISO, there's compose lens, compose prism, and so on, right? So we need to compose. So over here, you specify which one is on the right. So on the right, we're going to have ISO BC, right? So if you can go from A to B and then from B to C, then we obviously can go from A to C. And this is going to be the first function that you're going to see, you know, the first helper on the ISO is the one that allows you to go backwards, right? So you can take the ISO AC and you can just say reverse. Okay, now let's finally see an example of this. Okay, let's print out an ISO AC, right? This one over here. Okay, we can ask it just to get, right? We're not doing set or modify anything. Okay, so we need to give it an A, right? So we're just going to give it a 27 Bob, and we need to give it a dog, which is going to be a dog, and the name is going to be Snoopy, like this. Okay, so we give it that. What we're getting back is a C. Let's consult our C. Our C is a tuple of int and an owner. This is exactly what we have. This is a tuple. We have the int and we have the owner, and inside, you know, the owner's name is Bob, and the inside of owner we have a path, which is dog, right? Nothing super fancy. And just as a reminder, you can also convert an ISO into a lens, because if you remember the diagram, you know, ISO basically is, you know, a lens and a prism and an option, all of these things. Okay, so you can go over here and you can say ISO is a lens, right? So you can say a lens of CA is ISO CA, and in Monocle 3, probably this is going to compile. For now, you need to say as lens, like this. Okay, and it's called lens, like that. There we go. Now, in the previous video, you saw how Monocle can use macros to generate lenses for you. Now, the question is, can it generate ISOs for you? And I have some good news and bad news, but then I also have good news again. Okay, so the good news is, yes, it can. The bad news is it can only do this in trivial cases, and the case that we have right now is actually not so trivial. Okay, but then I have good news again. We're going to get to that in a couple of minutes. For now, let me show you the ISOs that it can generate. I'm not going to show you all of them. I'm going to show you the basic ones. Okay, so the first one is we can basically anonymize a case class, right? So we can take out a tuple out of a case class, right? So we can go over here. We can say, please give me the fields, right? So it's going to be an ISO that goes from owner to all the fields, right? So what is inside of the owner? Well, inside of the owner, there is a string and a dog, right? So we can have an ISO which basically goes from owner to a tuple of string and a dog. And Monocle can generate this one for us, right? So we can do gen ISO, and it's not apply, so we need to call another one called fields, and we need to specify owner, okay? Like this, okay? So what we can do now is we can get this tuple, right? Tuple of string and dog, like this. And how we're going to get it? Well, we're just going to go to fields and we will ask it to get it from the owner, right? So we need to give it an owner with some name, with some, let's actually do Bob, and we need to give it a dog, Snoopy, Snoopy, like this. Okay, so now we need to go and we need to print out this tuple, print tuple, like this. Okay, and as we can see over here, we have a tuple of all the fields. Sounds useful, right? So the next thing that we can do is we can produce an owner1 owner equals fields dot reverse, right? So we can reverse this ISO, right? Now we can get the tuple, right? The name is kind of confusing, right? We're not actually getting the tuple. We're saying get based on the tuple, right? So we're basically asking it to create an owner back from that tuple. Okay, we have owner1. Another way to do that, owner2, owner is going to be exactly the same thing. So there's a helper one called reverse get, like this, tuple, same thing. And a third one, owner, is fields apply tuple. Right, all of these are equivalent, right? It's a bit confusing that the get is actually the reverse get, okay? But all of them are the same, right? Print line owner1, let's duplicate that. We're gonna have a 2 over here, and we're gonna have a 3 over here, like this. Super cool. All right, the other one that it can generate is very useful actually. If you have things like final case class name, which has a value of string. It doesn't matter if it extends any val or not, but usually you would extend any val because you care about performance so much. All right, so we can now go and create an ISO that goes from name to string just by asking Monocle to generate ISO, right? So right now we don't need to do dot fields. We can use the apply gen ISO that goes from name to string, like this. Okay, and the same way you can do ISO reversed ISO string to name. For some reason, if you just do that, if you just do gen ISO string to name, it's actually not going to work, but it's not such a big deal because you can just always go to ISO and say dot reverse, like this. Okay, now I hope it's clear, but oh, we have the sprint line tuple. I don't want to have it over here. I want to have it over there. All right, now I hope this is clear, but we can actually go and do print line ISO dot get, and we can give it a name, which is my name, Vlad, like this. We can also do print out ISO reversed dot get. We can just give it Vlad, and it's basically like a factory for names now. Okay, and now you're gonna see, because it's basically a factory, this is exactly why apply is being created in such a way that it actually goes backwards, right? So basically, if you can go from name to string, then given this ISO, you can create names based on the strings, right? So going back is the apply. Like when I was learning Monocle, this was the confusing part for me, but now I kind of got used to this. Now, you might be wondering, how is this really useful? And in fact, it turns out that we actually already have an example for this. So what I'm going to do is I'm going to go and I'm going to collapse that one. And I'm going to try to uncomment all of these, and sometimes it works, sometimes it doesn't. Okay, it worked. So now I can go and comment this main in. Okay, so if you remember in the previous video, we ended up having this validation example, which has this weird transform thing. And the only reason for it was because we were not dealing directly with integers. We were working with these weird wrappers. Okay, so what we can do now is we can actually do transform. I'm going to call it transform simple, right? So this is the one that basically gets the value right in, okay, int, right? And it just does value plus 10, right? This is the essence of the transformation. This is exactly what I want to have, okay? So what I can do now is I can go and let me do it here for now, okay? So what I can do now is I can ask generate a lens, please, for the person with the age. And in fact, I can actually do no, I'll show you this one later. Okay, so I have this lens for age, right? But age is of type person.age, right? So if I do modify transform simple, it's not going to work, right? Because it needs transform with this type, right? But what I can do is, before I'm doing that, right? And also by the end, we also need to specify the person. Okay, before we're doing that, we can actually compose this lens. We can compose this lens with an ISO. Right? So over here, we just need to have an isomorphism between person age and person int. Okay, so let's ask Monocle to generate an ISO from person.age to int. Okay, and now it should behave exactly the same. We can throw this one out like this, maybe. okay, like this one, right? And now it's even so tiny, right? So it does exactly the same thing, right? So we're going from age 21 to age 31, okay? And now because it's so tiny, now we can finally, you know, throw it out and just do a plus 10 over here, right? Plus 10, like this, okay? So now we actually don't need these. We can throw both of them out, which is super, super cute. And now we can actually, you know, use even this fancy syntax, right? So we can do person.lens, right? Underscore age. Okay, so over here we can still do compose lens, right? So even though it returns a person, actually it doesn't return a person. Okay, it actually returns lens, right? So that thing, come on, show me. Yeah, it returns an apply lens, but whatever. Okay, so over here we can still do compose ISO. Actually, I can just take these guys. It's the same thing. I don't want to waste your time, right? So that, right? So this thing is exactly the same code. Okay, so now even though we have this complicated data structure, we can work with it as if it was a simple integer, right? So we're composing a lens with an ISO. Who would have thought that all of this math stuff was actually kind of useful? Now let's talk about our ace in the pocket. Remember, I said there's good news, there's bad news, but there's also good news again. Our ace in the pocket is chimney. All this time in the first video, we have been working with an isomorphism between the nested person and the flat person. Okay, so what we can do now is we can go and use chimney to help us generate this isomorphism, right? So even though Monocle is not smart enough to do that, we can use chimney to at least alleviate some pain. Okay, so we already have these methods that go, you know, they go to flat and to nested, right? And if you remember, if I jump into them, we're using chimney over here to help out with that, right? It helps out, you know, only with the flat parts, but you know, still, it's better than nothing. Okay, so if we go back to our main over here, we can actually go and let's do it over here. Okay, so we can create an ISO between nested and flat like this, and we cannot generate it, right? But we can do ISO nested flat. And what does it want? Well, it wants to know how to go from nested to flat. Well, there's a function called to flat, and it also wants to know how to go back, right? So when you go back by that to nested. Okay, so now we're gonna have a couple more print lines. In fact, I sort of want to remove this one, and I want to remove that one so that you can kind of see more. Okay, so we have the flat and nested, and now we're gonna go and have a couple of print lines. They're gonna look a bit ugly. Okay, so we're gonna do that. And so what we're going to do is we're going to take the ISO and we're going to ask it to modify, right? So the idea is that we have this nested person, and if we didn't have lenses, it would be really, really hard to modify. Let's imagine for now that we don't have lenses for the nested ones. So the idea is that we can work with the flat person, right? So we can describe how to modify a flat person, but we can apply this modification to a nested person. Okay, so I'm going to say ISO modify, and I'm going to say, okay, so let's say that this is a flat person, and we're going to do flat.copy, right? So let's say that we don't have lenses, don't have anything, right? So we can say, this is how you modify the street name. Just going to do style flat.street name, right? But now we're going to apply this whole thing to nested, right? So we're going to give it nested thing. It's going to, what it's going to do is basically it's going to take the nested, it's going to convert it into flat, right? Not the super most efficient thing, right? Then it's going to do this flat.copy, and then it's going to convert it back to nested. Okay, let's see if I made any typos. It looks like I didn't. Okay, so a shorter version to write this would be print line. Okay, let's do ISO.modify, right? Modify, and over here we're going to do .lens, .street name, right? .modify. I'm just playing at this point. Okay, style nested. Okay, so essentially instead of doing this copy, where we're using the lens syntax as well. Okay, another one is to notice that we're actually calling modify twice. This actually means that we're composing something. Okay, so let's allow Monocle to do this thing for us. We can do ISO compose lens. Okay, now we need to give it a lens, gen lens for flat for street name. Okay, and now we can say modify styled, and now we can say nested like this. All right, and the last one is going to be like that. We can do nested dot lens, and we can do dot address dot street dot name dot modify.stat, right? So I'm basically showing you that without the ISOs, you basically don't need it, like in this particular case, because we're dealing with a case class and we can drill down with a proper length, right? So all of these are longer than this one, and in fact this one is even more efficient because it doesn't need to create the intermediate data structures, right? So for this particular case, these were essentially bad examples. All right, so let's talk about the laws. If you go back to the page, and let me zoom out of Chrome, and if you go to any of these optics, right? So let's say that we go to ISO. At the bottom of them, by the way, the documentation is actually really good. At the bottom, you're going to see the laws, okay? And basically, you don't even have to implement the laws yourself, because if you include if you go back to main menu, if we include this library over here, right, then what it does basically, it has Scala check properties for you. All you need is to check them, right? So you create your ISO, you create, you grab these properties from the Monocle law library, you put them together, you ask your testing library to check it for you. This is exactly what we're going to do actually, right? So let's go back to optics, let's go back to ISO, and it will basically say that you can just grab the ISO tests from the law module and run these tests. Basically, these are simple round trip tests, right? So that you can go back and forth and the same thing is going to come out. Okay, so what we're going to do is we're going to go over here. We're going to go into the build, build like this. So this is where we have our dependencies. These are the production dependencies and these are the test dependencies, right? So we need to add one for Monocle law, and it's going to be a test dependency. So I'm just going to do a comma over here. We're setting to have more test dependencies than we have the production level ones. Let's make sure that they're sorted. Yep, they are. Okay, so let's go and save that. Okay, let me actually go and show them to you. It's over here. We have Monocle law over here, right? Basically does the same thing as on the website. Okay. Now, if I were to import the build, in fact, this is what I'm going to do. I'm going to go and I'm going to import the build for a bloop. A bloop will actually show you that we have a problem. We have a problem in our test suite. Right, so if I'm gonna go to our test suite, right, so the problem over here is, as we will see in just a second, that our dependency on Scala test is 3.8.0. If I go to dependencies, we're gonna see 3.0.8, right? But Scala test 3.1.0 is actually already out, right? So the thing is that I didn't want to update to 3.1.0 because there is some discrepancy which has to do with the properties in Scala check. In fact, this thing is not going to compile if we update to 3.1.0. Long story, the point is that I want to show you that if you go to Metals has this thing over here. It can show you which libraries you depend on, and you will see that we're actually dependent on Scala test 3.1.0.snapshot, and I don't want to have that. I also don't want to fix this warning. So what we can do is we can go back to our build and we can create another one of these. It's going to be called dependency overrides. Plus equals sequence, right? So it's exactly the same pattern over here, and we can basically specify Scala test. Again, Scala FMT is going to remove that comma for me. Okay, so if we import the build now, I actually don't even need to show this to you because the warning is simply going to disappear, right? So it's going to enforce that we're going to use the lower version, right? So what happened basically, the Monocle law brought in the dependency of Scala test 3.1.0 snapshot 13 or something, and I don't want to have that. Okay, so it partially failed for some reason. There's probably a typo. Build dependency overrides. There should be an S. Okay, let's retry over here, and let's also import the build. All right, so everything's gonna be fine. In fact, what we also we will need one more thing, and I'm gonna explain a bit later why we need it. I'm gonna copy it from my script. So the thing is that it should be super simple to write these tests, right? Because you already have these ISO tests from Monocle law, and you already know how to create ISOs, so it should be super simple to put them together and just to apply that. But it turns out it's not super simple, which is exactly why I'm showing this to you. Okay, so in fact we need to go to dependencies, and we need to add another library called kittens. And if you have never played with cats or kittens, then don't worry, I'm going to explain exactly what each of these libraries do. In fact, for these tiny tests that we're going to write, we're going to need like 10 freaking imports, okay? So we need to go back to build, and over here we need to say that we want the dependencies dot, I believe it's cats dot kittens, like this. I believe this should be fine. Right, so if I do that, let's go and see if I can import the build like that. Yeah, just double check with my script. In fact, we do need kittens, but we actually only need it over here in Scala test. Okay, so let me save, and let me actually go here, and let me sort the file, sort the lines over here. Okay, so we have the dependency on chimney, and we have the dependency on Monocle macro, which brings the dependency on Monocle core, and also it brings the dependency on cats, and we have a bunch of stuff over here for our test. Let's import the build. Okay, so let's go to our example suite. Right, so this is just an example, and just as a reminder from the very first video, we're using one of my jittery templates. So if we're going to go to the terminal and we're just going to go and run the test, we can actually throw out this test because we don't need it. Okay, so what I'm going to do is I'm going to write out the test first, and then I'm going to bring in a bunch of imports that make it work. Okay, so what we're going to do is we're going to say, let's test the ISO. Okay, let's test the ISO. Right, and for that I'm going to import person.raw. That import kind of doesn't count. Okay, so we create our ISO. We already know how to create our ISO. In fact, maybe I can just go and grab it from main. This is our ISO. Okay, right, this is our ISO like that. Okay, so now we can go grab our tests. It's not going to compile for quite a while actually, right? So we can do ISO tests dot rule set. I just wanted to show you the type, right? So we can just do ISO tests, and we just give it our ISO, right? So it should be simple like that. Okay, now because I'm using Scala test works in such a way that it only fails when we throw an exception. And the way properties work in Scala check is that they just basically return an equivalent of a false. Okay, and so we need to make sure that we're actually testing these properties and not just like leaving them hanging over here. Okay, so the first thing that we need to do is we need to actually get the properties. It's going to be the sequence of properties out of these tests, right? So out of this ISO test, we need to say .all, .properties, and it gives you a sequence of tuples with name and the property. We don't need the name, so we can just grab the property and we can convert it to seek. This is a Scala 2.13 syntax, right? So we're passing in the companion object instead of the type as you would do in Scala 2.12. Okay, so you can just do to seek like this, right? And now we need to do properties dot for each check like this. Notice that this would also compile, but it's not doing exactly the same thing. Okay, it's weird. I know. This is exactly why I'm showing you how to do this. Okay, so for all of this, we need a bunch of imports. The first thing that we need is we need to explain to cats, which is a highly functional library, which doesn't like the fact that equality is defined on any on the JVM. It basically created a type class called EQ, right, which defines the method equals, right? And we need to generate instances for nested and flat, right? And there's a way to generate them with macros, and this is exactly what kittens is for, right? So we can do import cats derived auto EQ. Okay, so this is going to make sure that we can compare nested and flats. The other thing that we need is we need to import cats implicits. Import cats implicits, right? So it's basically for exactly the same thing, right? So that we know that this this class is there derived like that. Okay, the next thing that we need is, well, from Monocle, actually we need the ISO, and we also need monocle.law.discipline.iso tests. Okay, this one. Okay, so the other thing that we need is we need from Scala check, right, which we also have on the class path. We need the prop, right, because I specified it over here, right, because I was very explicit. Okay, we also need org Scala check dot Scala check shapeless. In fact, let me actually go back to the dependencies and show this to you, right? This has been in there all along, right? So this is an integration of Scala check and shapeless, a library which can allow generic programming for you. So basically it will generate the arbitraries that are required for the Scala check properties. If you have never played with Scala check, I have a video about this, check it out. Okay, I didn't jump into the example suite. Okay, so we have these, right? So now we can generate arbitraries for nested and flat. Right? So now we can basically Scala test or Scala check, they know how to generate nested and flat. Okay, and we also need to import the integration of Scala test and Scala check. And because Scala test is going through a major rewrite, and this thing actually changed. So it's like that, Scala test plus Scala check. Okay. And what this brings is checkers, right? So what we can do now is we can do with checkers, okay? And I believe I have a tiny typo over here. It should be ISO tests like this, okay? So now I believe we actually have everything, almost everything. I need to have an underscore over here. Okay, so now we have everything. Now everything compiles, and now our test should be green. And I want to show you that it works by basically ruining one of this. Okay, so for example, over here, I'm going to say copy name equals blah, right? So now this is not a true isomorphism, and now it's going to fail. Always make sure that your tests fail. Okay, so over here we're going to see that it basically generated some stuff, and then it failed, right? So it failed for it looks like it failed for a proper reason. Okay, so tests are really important, and as you have seen, it was a bit painful. Okay, but you can you can abstract a couple of these things away. Essentially, Monocle and all of these other libraries, they take this pain away from you. It's super important. Please always make sure, do yourself a favor and write tests for all of your optics. I showed you how to do this with ISOs, but every optic has its own laws. Essentially, go to the website, scroll down, there will be the description of laws, but essentially there will be ISO tests, and there will be, I don't know, Prism tests and so on, right? Prism tests, all of them are in there. The other thing that I want to say is that I didn't have enough time to play around with Scala tests, so maybe there's an even better way to do this. Just please make sure that it also fails when it is supposed to fail. Okay, so we're pretty much done playing around with ISOs. In fact, I'll go back to our main method. Okay, we pretty much covered lenses extensively in the previous video. I'm just going to show you one tiny thing that that I sort of forgot to show you in there, and technically it doesn't have anything with lenses. It has something to do with function composition, right? So remember, if you're calling some method on a lens, what it gives back to you is a function, right? So if you're calling modify, it gives you a function that knows how to it gives you a function that goes from nested to nested, for example, okay? And you can compose these functions. And this is useful when you want to set multiple things, right? So you have a lens usually can set or modify one thing. If you compose lenses together, then you can still at the end only like modify one thing. But if you get the functions out of your lenses and you just compose them simply as you would compose any other functions, then you can actually set multiple things. Okay, so what I'm going to do is I'm going to show it to you. Let's get rid of all of these print lines, all of these ones. Okay, yeah, so this is exactly what I wanted. So let's say that we had our street lens again, right? So we have the street name. We actually should still have it. Where is it? I removed it. Okay, I shouldn't have. I'm going to copy it so that I don't waste your time. Okay, so if we have these two lenses, okay, so let's say that we wanted to modify both. We wanted to modify the street name, and we also modified want to modify the zip code, right? So what you can do is I'm going to annotate all the types so that it's clear, right? So you can just grab the function, right? So you can go to street name, right? And you can ask it modify, with styled. Styled is our helper that just makes it green. Okay, so what this returns is a function that goes from nested to nested, right? And you can do the same thing. You can rip out the same function from this one, right, like this, and now you can do either after G, right, which means it will modify the street name first and then the city zip code, which doesn't really matter, right? So you can do f compose G, or you can do G after f, which is f and then G, okay, and you can print out f after G with nested, and you can do the same thing with G after f, right? So the f is small like this, G after f, right? So both of them, they produce exactly the same thing. Basically, they go and modify two things instead of one. Okay, and I'm pretty much playing at this point, but what I usually like to do is if you have more of them, I like to put them all into a sequence, right? So I like to do something like a sequence of f, f comma G, and then at the bottom I'm just going to do reduce left, and I can do you can do compose, or you can do f then. It doesn't really matter. Okay, so basically what I usually do at the end is I just inline everything like that, right? I just do this, and I just do that, right? So now you can remove all of this stuff, right? All of that, all of that, right? And you can apply this thing, for example, to nest it, right? And we could also print out the entire thing, print line like that, right? So just inline the whole thing, okay? And we also need to do, we need to modify over here, right? So we need to modify like this, modify styled like this, okay? In fact, maybe we can actually do, hold on. Maybe we can actually do map to dot modify style. I'm not sure if we can do that. I don't think that we can do that. Can we do that? Oh, we can. Yeah, that's great. Okay, so you can do that, and maybe Scala FMT can help out with that. All right. So basically, you have like these two lenses. You map each lens to exactly the same modification, which is not what you would usually would do. In fact, let me revert that. I don't like that. Okay, and just as a reminder, because you actually have this fancy lens syntax, it actually allows you to go even even better about this, right? So you can, instead of this, you can actually do print line. You can do over here nested. Okay, then you can request the lens for that thing. Okay. Okay, so now we can ask it to modify style. Okay, so now this gives you a nested back. Well, if it gives you a nested back, then you can do lens again. Okay, right? Then you can do this address dot city dot zip code, and you can do modify styled again, right? So this thing will essentially produce exactly the same thing, right? So this is actually the preferred way to do this. Okay, this is how you modify or set multiple things, right? So you don't need to do modify. You can also do set, and now you just need to give it some string, right? So you can so the zip code is now this weird thing, right? So you can do multiple you can do different modifications to each field, but you can modify all of the fields at the same time. It's not as efficient as doing it directly, right? Because because behind the scenes still there's lens composition, or at least function composition. So intermediate data structures are created, right? But most applications these days are I/O bound and not CPU bound, so we're good. All right, let me comment out these couple of print lines, and let's start talking about prisms. Okay, right. So this is exactly what we have. In fact, I don't want to waste your time. So remember this example of traffic light that I was explaining to you before, before we started writing any code. I'm just going to go and paste it, right? I press Ctrl+Shift+V again. Okay. So this is a simple traffic light, simple ADT. We have red, yellow, and green just for fun. I threw in opacity in there for some reason, as if traffic lights could have opacity. And I also have fancy two strings in there that use ANSI codes to print out red actually in red and yellow actually in yellow and green actually in green. Okay, so what we can do is we can go and print out traffic light dot red 0.8, for example, just for fun. So we can have red, we can have yellow, and we can have green. All right, so they're printed out actually in red, actually in yellow, and actually in green. So now let's go ahead, and I'm going to show you multiple ways of creating a prism that zooms only into the green one. Okay, so I'm going to do prism 1, right, and it's going to be a prism that goes from traffic light to traffic light dot green, like this. And as always, it's defined in terms of these two functions that go back and forth. Okay, so I'm going to have traffic light and traffic light dot green. Okay, so the first function is basically going to go from traffic light to green, and the second function is going to go back from green to traffic light. And as a reminder, prisms, they can always go back. So going back is simply identity, right? Because the green traffic light is a traffic light. Okay, so this one was simple. Okay, but for this one, we need to make sure that we're grabbing the green, right? Only if it's green, traffic light dot green, right, with some stuff in there, right? And then we need to return a sum of green, right? And we need to not forget to also match on the other cases and return a none over here. Okay, let's see if I made any typos. It looks like I didn't. Okay, so what I'm going to do down here is I'm going to have a sequence of prism 1. In a couple of seconds, we're going to have prism 2 and prism 3 as well. Okay, and for each of them, we're going to grab the prism. Right? I just want to show you that there are different ways of creating it, and they're all doing the same thing. Okay, so we can print out and we can do prism, and remember there is this optional notion about the prism. So there is no get, but there is get option. Okay, there is get option, and now we need to give it a traffic light. Let's give it basically that one, the red one. Okay, like this. Duplicate that, and I'm going to use yellow, and I'm going to use green, and also I'm going to comment out in these print lines. Okay. All right, so in the first two cases they failed, but only once it was green, it actually passed. Okay, so another way to do this would be to do, let me actually copy that. I'm going to copy that, right? I'm going to paste that. I'm going to call it Prism 2. Let Scala FMT do its thing. Okay, so there is a helper, right? So there's a helper where you can do Prism dot partial, right? And if you do Prism dot partial, then you don't need to have this second case, right? You can just do that, and also you don't need to produce a sum, right? You can just go straight to green. Okay, and because this is an ADT and because Monocle is awesome, you can also just ask it to generate it, right? Prism 3, we can just ask it to generate a prism that goes from traffic light to traffic light dot green. It cannot go straight to opacity, right? It cannot generate a prism that goes straight from traffic light through green to opacity, but we can actually compose a prism with an ISO, which we're going to see in a couple of seconds after I show you that it actually behaves the same. We will see that after this composition we will get exactly what we want. Okay, so we're getting the same thing every time. None, none, and then a sum, none, none, and a sum, none, none, and then a sum. All right, so what we're going to do is we're going to create now a rather typical prism, right? So the one that I showed you, I just wanted to show you that Monocle can actually generate them. But a typical prism would actually be the one that I just described. It would be the one that goes into the opacity. Okay, so let me do that. Okay, and let me go over here, and I'm going to say val typical prism. Okay, so this one is going to look pretty much the same, but it's going to go not only to green, it's actually going to go all the way to the double. Right, to the double. Okay, so this means that we need to generate it ourselves, right? So one way to do this would be to do prism.partial, right? So the same as over there. Okay, traffic light and double, like this, and we're pretty much going to have a similar pattern match, right? So we're going to pattern match on green, right? But now we have the opacity, and now we can grab the opacity and return it over here. Okay, right? And now over here we can't use identity because we're not going from green to traffic light. We're going from double to green, okay, or at least to traffic light. Okay, and so we can just do a traffic light dot green, right? Or basically we're using the we're using the apply. Okay, opacity, right? So essentially we're using the apply, right? But we can also just do that. Okay, so this is our typical prism, and let's go and print it out. So we can do I'm gonna grab these. Okay, I'm gonna grab these. Okay, I'm just gonna paste them over here. Remove that. Let's use the typical prism, like that. Okay, so now we have none, none, and we have sum of 0.8, right? So if I scroll up, if you remember, before that we had the sum of green 0.8. Now we just go straight to sum 0.8, right? So only if it's green, only then we're gonna rip out the opacity. And the reason I'm showing you this is that there's still a better way to do this, right? By composing things. Okay, so you can go and you can say I'm gonna duplicate this line. Okay, so I'm going to say this is a typical prism 2, and we already know that it can generate this one, right? So it can go from traffic light to green, right? And we know that we can also have an ISO between green and the double, right? This is the one that we had before. Remember, with a name, and the string was inside. Okay, so we can essentially compose this with an ISO, right? We can say, hey, please generate an ISO that goes from traffic light dot green into a double. Okay, and this will behave exactly the same, right? So in fact, I'm going to remove the top one because we don't need it, right? So I'm going to have this prism, and it behaves exactly the same. And the other example that we're going to have is, instead of get option, this is kind of boring, right? So instead of get option, we're going to do modify. Okay, so instead of this, we're going to do modify, and the modification is just going to be +1. Okay, so it's only going to modify if it's if what's inside is a green. So as you can see, it only added 1 to the green, but not to the yellow and not to the red. Okay, so it left them alone. Okay, so the next thing that we're going to have is we're just basically going to have fun with this stuff. So we're going to compose a prism with another prism. Okay, so we're gonna comment this out for now. In fact, we're not going to comment this out. We're going to leave it. Okay, so I'm going to have over here, I'm going to have a prism, right? So we have the ones that are called 1, 2, 3, and we have a typical prism. So this prism is going to go from traffic light to int. Okay, so what we're going to do is we're going to start with our prism, right? That goes into the double, but only if it's green. Okay, and what we can do is we can compose it with another prism. Right, we can compose it with another prism. This is going to be a prism that goes from double to int. Okay, right? So again, it needs two functions, right? How to go back from int to double? Well, that one is simple. It's just two double, like this. This one is a bit more complicated, right? So this one basically says, okay, double comes in, and come on, double comes in, and there's a chance that this double is not an integer, right? So 0.8 is not an integer. So we need to check, and this is how you check it on the JVM, right? This is how you check it, that this is an integer, okay? Then you can produce a sum of double dot to int, then you know that it's going to work, and otherwise we're going to produce a none, like this, okay? So this is an even more typical Prism, right? So this is where you see the power of composition, okay? So now we're just going to replace typical Prism with Prism over here, right? And we're going to see that it didn't do anything for any of them, because none of them actually were were an integer, right? So only when we have an integer like 1 or 2, only then it's going to apply this modification, right? So it needs to be green. Okay, then that it needs to be double, but it's always a double inside, and only if it's an integer, only then we're going to apply this modification. Also, you can kind of smell that there's a lot of basically pattern matching going on behind the scenes, and it turns out that you can use a prism in your pattern matches, right? So if we have a green, for example, with a 2, like we have exactly over here, then we can just match, right? Over here, you just use the lens, right? Case prism, you can get the value out, and we can print it out. Right. So in this case, traffic light. Okay. So in this case, it's going to match, and therefore we're going to see 2. As soon as we do, I don't know, red, for example, it's going to throw an exception. Or if we do green, but we're not going to have an integer here, we're going to do 0.8, for example, right? It's still going to throw an exception. It's still not going to match, right? So you can use prisms in your pattern matching, right? In your pattern matches. So prisms essentially are extractors. Okay. And last thing sort of to remember is that you can also always go backwards, right? You can always go backwards, so you can use your prism as a construction of a green, right? So if you give it a valid integer, it will be able to construct a green. All right, print line prism tool like this. Let's throw these ones out. Right. So only if it's a valid, valid integer, it's gonna produce a green. Now in this case, we kind of get lucky because now we can't even pass in a double. It's just not gonna compile, right? We're not always that lucky, but in this case, it's kind of good to know that that the compiler has your back. Okay, so essentially you can use a prism to construct a green, and you can also use a prism as an extractor for green with a double which is an integer inside. All right, so we're not going to write any tests for prisms, but as already mentioned, go to the website, click on prism, go down, there will be the law, grab that and write the test basically in a similar way as we did. So now we're going to talk about optionals, but we're basically at the end of the video, so I'm just going to show you one example. Okay, so what we're going to do is we're going to go and create an optional. It's going to be an optional of int and string, right? So this is going to be a standalone example. This has nothing to do with traffic lights anymore. For now, I'm starting to lose my voice here. I'm sorry. All right, so we're going to grab this guy over here, and we're going to go over here, right? So it needs to have, so what we're going to do is that it's only going to be optional. So optional means that, we can fail retrieving a target from a source, and we can also fail coming back from the target to the source, okay? So this optional is going to, it's going to take an integer, and it's only going to convert it into a string if it's an even integer, okay? So this is the first function, the one that goes from source to target. Int modulo 2 equals 0. Well, in this case, let's do int dot to string, and otherwise we're going to do none. I hate this auto-completion. It covers the entire code base. Okay, it makes it really hard to record tutorials. Okay, and the other function is going back, right? So if we have a string, right, and this is, remember the lances, so optionals are very, very close to lances. Remember that the lens, it needs, if you're creating a lens manually, right? So if you don't do, gen lens, if you're creating a lens manually, then you need to give it a function that, given the new value, right, the new string, and given the source, which is the current int, okay, because you need, for the lens, remember, you can't go back from target to source. You need another thing. You need another source. You need a target source to go back to source, right? So this is our target, and this is our source, and now we can basically do our test, right? So we can do string dot to int option, okay, which came in Scala 2.13, which is really great, and we can make sure so only if it's even, right? Only if it's even. Otherwise, we're gonna get or else current int. Okay, so if it's not even, right, so that thing that you're setting or that thing that you're modifying, if what comes out of it is not going to be an even option, then we're just gonna grab the same thing as we had before, right? So this would be the so in Lances this was a case class, and this was the street name, for example, right? So this was a nested, and this was a street name, right? And so essentially what we're doing here is we're saying, okay, if the street name is Ron or something, then we're just gonna keep the case class, okay? Let me show you a couple of examples over here, right? So we can go and do print line optional, same as Prism. It doesn't have a get, but it has a get option. And let's do 99, for example. Okay, it's none, right? Let's do the same thing with 100. Okay, and now it's a sum of 100, and it's not 100, it's a string, right? Because it's a conversion to a string. Okay, so over here we can do, for example, map dot reverse, right? So we're calling reverse on the string, right? So we have 001 and not 100. Okay, and we can also do optional. We can do modify, right? So we're describing how to modify a string over here, but what comes out is actually an integer, right? So over here, what comes out is an integer. So we can do, for example, plus 10. Okay, so we have 110. So essentially, this is the addition on integers, right? So the type that comes out over here, it is an integer, like that. Okay, right. So let's go a little bit crazy. This is going to be our final example. Let's create a crazy optional. Okay, so this is going to be an optional that is going to go from traffic light, right? So it's going to take our prism that we had that was already crazy enough, and then it's going to go to string like this. Okay, so essentially what we're going to do is we're going to grab our prism, which was called simply prism. This one, okay, this is going to be prism, okay, and now we're going to compose it with another prism, okay. Hold on, I'm doing something wrong. I wanted to grab this one. This was the, oh, it's already composed. Okay, so we're gonna have I want to do it like sort of manually, right? So I'm gonna copy this this code over here, right? So I'm gonna have this thing so that you see the whole composition. Okay, so we have the typical prism that goes from traffic light to green. Then we're composing it with a hold on, typical prism is not. Let's maybe also grab this one. Let's also grab this one. I want to have everything in line so that we have the entire example. Okay, so we have a prism that goes from traffic light to green. If it is green, then we're going to grab the opacity, right? And then we're going to make sure that the opacity is an integer. Only then we're going to grab it. And then on top of all of that, we're going to compose optional with our with this one, with this guy, with this optional. Okay, with this optional. Okay, great. Let's see if it compiles, and it looks like it does. It looks like it does. Okay, so now it's going to be really hard to make it match. Okay, so we're going to do crazy optional dot modify underscore reverse like this, traffic light dot red. Let's do 11338 like this. Okay, let me remove the other print lines. Okay, so what we're trying to do here is we're trying to reverse this number. Okay, so let's do green, and let's do green with .2, right? Not gonna work. Okay, let's do green with 1337, right? It's not gonna work. So now it's an integer, right? But it's not an even integer, so we need an even integer. Okay, we need an even integer. Okay. And now it's still not reversed because we need an even integer that is reversed also an even integer, right? So we need to start it with something even, right? So over here, 2338, right? Only now it matched, right? So now it matched, and now it reversed it, right? This is really crazy, right? And as a reminder, obviously for red, it's not going to work because it's going to fail at the very beginning. Okay, this is really, really crazy, right? So we essentially have a thing that goes from traffic light into green, into the double inside, then into the end, then into the even, and then into the reverse, right? But only also when it's even, right? So this crazy thing, this crazy complicated logic composed out of these small pieces, this is really, really wonderful and also really, really typical for functional programming. All right, I know that optional was a bit too crazy. Just remember that it also has laws, and you also need to write laws for them. Okay, just make sure. And also, as mentioned in the beginning, this video, I knew that this video is going to get so long, and so I knew that I'm not going to be able to cover the traversals and fold. I'm also not planning any more videos about Monocle, but if you guys want another video, let me know. I might sneak it into. It's going to be a super short one, right? So traversable and fold, they're very, very similar, but they can they can modify multiple values and not just one. One tiny reminder, as already mentioned, if you're composing a bunch of lenses together, then your data structure is going to go through a bunch of transformations, right? So even if you compose just lenses together, right? So this is technically a bit less efficient, right? So a lens that is just generated by Monocle is going to be pretty much exactly it's going to be exactly the same. It's going to have exactly the same execution speed as your manually written copy methods. But as soon as you start composing them, then you're going to create intermediate data structures, right? So it's basically the same thing as having a list and then mapping it to something and mapping it again and mapping it again. It's essentially the same thing. Luckily, though, as I already mentioned, most applications are not CPU bound; they're IO bound, and so it's actually it works out. It works out all right usually in production. And if you have some issues, make sure to profile your application instead of just simply blaming it on Monocle. Make sure that it's that the bottleneck is actually there. Also, make sure to not just watch my videos or in fact anyone else's videos. Make sure to go and play for yourself, because I can't possibly cover the entire libraries in here. Okay, I can't show you every little trick. I was just having fun myself. I recorded the video about this, but make sure that you play around with yourself. Also, otherwise you're just gonna forget. But not now. For now, just as always, it's been Vlad, devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider support me on Patreon. But most importantly, take care.